Welcome back. In the previous part, we just spoke about the gradients, and now what we're going to be doing is we're going to be talking about the applications of gradient. How does that look in analytical geometry, and how are we going to use that going forward? So the first thing that we're going to be talking about is points on a straight line. Now, the definition of a straight line is a set of points with a constant gradient between any of those 2 points. So here what I've done is I've drawn a line. Here you can see A and B and C. And if I ask you guys, does that look like a straight line? Is it a straight line? Well, obviously it's not. It definitely isn't a straight line. But what do we see here? That this line, oh, and sorry, let me go back here. This line is less steep than this line. This gradient is not equal to this gradient. And so because the steepness is not the same, this is not a straight line. Whereas if I look at this line here, I've got 3 points here, A and B and C. And does everybody see that the gradient M between the first 2 points and the gradient M between the second 2 points, the steepness doesn't change. It's exactly the same steepness, and because the steepness doesn't change, it's a straight line. And so if they give me 3 points and they ask, is this a straight line? All I need to do is I need to look at the steepness on each of these sections and ask, is it the same? Because if it is the same, then it is a straight line. If it's not the same, it's not a straight line. And so let's do an example of that. Here they ask us, do the following points lie on a straight line? So I've got 3 points here. And so all I'm going to do is I'm going to work out the gradient. Oh, sorry, that M was not nice. There were 3 loops in that. If I work out the gradient of AB, and I work out the gradient of CD, the question is, are they the same? Sorry, not of CD. Of the second 2 points, which is BC. So if I work out the gradient of the first 2 points, that gradient, and I work out the gradient of the second 2 points, BC, if they are the same, it's a straight line. If they're not, then it's not a straight line. And so very simply, let's go do that. Let me just erase here so I've got more space. And what do we do here? We said I'm going to take the y value and subtract the y value. I'm going to take the x value and subtract the x value. What I've got at the top, minus 3 minus 1 is minus 4. And at the bottom, 5 minus 1 is positive 4. And the gradient of the first 2 is minus 1. What did we decide? If it was positive, it was going up. If it was negative, it was going down. So this is a line going down. Now, let's look at the gradient of the second one. I'm going to go the y value of the second point minus the y value of the first point. So it's going to be minus 1 minus 3. Again, crucial. If I'm subtracting a negative value, I'm going to put that in brackets. And then I'm going to go the x value minus the x value, 3 minus 5. And what I get here, minus 1 minus 3. Let's actually do that on our calculators, make sure that we get that right. So let's choose this. I'm going to go minus 1 minus 3. And at the bottom, I'm going to go 3 minus 5. And what do I get? I get a gradient that is also equal to minus 1. And so the gradient, the steepness on the first section, was the same steepness as the second section. And therefore, I can definitely say this is a straight line. Okay, so if we do that, if they ask us, do the following points lie in a straight line, all right, the first 2 points are the same, and so the gradient of the first 2 points is minus 1, all right? But if I look at the gradient of the next 2 points, let's calculate that. And what did we say? It was going to be the y value minus the y value, so it's going to be 0 minus 3 in brackets to make sure that I subtract the negative. And then I'm going to go the x value minus the x value, 3 minus 5. Let's go back to our calculator, put it in. I'm just going to navigate. I'm going to navigate to the top here, and I'm just going to make that a 0 at the top. So 0 minus negative 3 over 3 minus 5. And what do I get? Negative 3 over 2. What is that? That's negative 1.5. I'm going to leave it as negative 3 over 2. But does everybody see that the gradient between A and B is not equal to the gradient between B and C? And so therefore, A, B, and C do not lie on a straight line. Awesome. So we can always see if 2 points lie, or 3 points lie in a straight line by checking the gradients and seeing, is the steepness of different sections the same? That's the first application that we're going to be talking about with gradients in analytical geometry. Awesome. So we saw that it didn't lie on a straight line. Now, the next part that we're going to be doing is exactly like with the gradient. We worked out the gradient. Now we're going to be working backwards. So the next question says that find A if these 3 points lie on one straight line. So now we're starting with the end point and we're working backwards. So they are telling us that these 3 points lie on a straight line. So what is that saying? What that's telling me is that the gradient between these two, the gradient of AB, is equal to the gradient of BC. So they are telling me it's on a straight line, which means the gradients are the same. And so that's my starting point. That's where we're going to start. And so I'm going to somehow try set up an equation to calculate what A is, but I'm going to be starting with the fact that the gradients must be equal. So let's do that. The gradient of AB is equal to the gradient of BC. And so let's go calculate the gradients of AB. What did we say? It was going to be the y value minus the y value. So I'm going to go minus 3 minus A over the x value minus the x value, 5 minus 1. So the gradient of the first section must be equal to the gradient of the second section, which is going to be minus 1 minus, and again, when I subtract a negative number, I'm always going to put that in brackets. So it's going to be minus 1 minus minus 3 over 3 minus 5. Now, we're cheating a little bit because these are the same values that we had in the previous question. And so I know what this answer here is. That answer there is equal to minus 1. And on this side, I've got minus 3 minus A over 5 minus 1, which I know is equal to 4. Oh, sorry. I don't know what's happening with my eraser here. So let's just go back to that slide. Cool. Let's choose the eraser. All right, so we had 5 minus 1, which is equal to 4. And now all I need to do is I need to isolate A. So I'm going to multiply both sides by 4, because then the 4s will cancel out, and I'm left with minus 3 minus A is equal to negative 4. I'm going to add 3 on both sides, or take the minus 3 to the other side, which will give me minus A is equal to minus 1. And then all I need to do is get A alone. Again, they didn't ask me to solve for negative A, they asked me to solve for A. How do I get it alone? Well, in front of A, when we talk about minus A, we're actually talking about minus 1A. And so if it was a 2A, how would I get rid of the 2? I would divide by 2. And so if it's a minus 1A, how do I get rid of that minus 1? Well, I divide by minus 1 on both sides, and I'm going to end with, let me continue here, A is equal to negative 1 divided by negative 1 is positive 1. And so I know that A is equal to 1, which we actually knew was the answer because this is the same question that we did earlier. But again, so what can we do? We can see if 3 points lie on a straight line, or what we can do is we can say they do lie on a straight line, solve for something by setting up an equation. That was the first application of gradient within analytical geometry. The second aspect of gradient that we're going to be looking at is parallel lines. Now, when we look at parallel lines, two lines that run parallel are always going to be the same distance apart and have equal gradients. Now, that is the crucial part. Parallel lines have got equal gradients. Why? Because they're equally steep. They've got the same steepness, and so they're going to have the same gradients. And so here they say, and we're going to jump straight into the question, it says, show that the line AB is parallel to the function y equals 2x minus 2. Now, from functions, we know that the coefficient of x is the gradient. And so I know that the gradient of this line is equal to 2. If the first line has got a gradient of 2, then those lines must be parallel. They have the same steepness. And so let's work out the gradients of the line AB. If I do that, I'm going to go y value minus y value. So I'm going to go 6 minus 2. And here I'm going to go 2 minus 0, x value minus x value. And what do I end up with? I end up with 4 divided by 2, which I know is equal to 2. And so this gradient is equal to 2. What did we say about the first line? Well, the first line also has a gradient of 2. Their steepnesses are the same. They must be parallel. Awesome. So the third aspect that we're going to be talking about with regards to gradient is perpendicular lines. Now, perpendicular lines, we know, are two lines that intersect at 90 degrees. They intersect at right angles. But what we discussed in functions and what's important is that the product of their gradients is equal to -1. So if I take the gradient of the first one and multiply it by the second one, I'm going to get an answer of -1. Okay, so we're going to jump straight into the question like we did with the parallel lines, and they tell us that the first line, AB, is perpendicular to CD. So they're telling us that these two lines are perpendicular. What does that mean? That the product is equal to -1. So if I multiply the gradients, it's equal to -1. And they want us to find y. Now, we've done questions like this. This question is asking us to set up a gradient. So if I take the gradient of the first one and multiply it by the gradient of the second one, I'm going to get an answer of -1. And so that's what we're going to do here is I'm going to take the gradient here. I'm going to go 6 minus -2. I'm going to divide that by the x value minus the x value. So it's going to be -2 minus 6. And I'm going to take the first gradient and I'm going to multiply it by the gradient of the second one, CD, which is going to be the y value minus the y value, y minus 3, divided by x minus x, 7 minus 4. And this gradient, or this answer, must be equal to -1. What I've done here is I've set up an equation, and what I can do is I can go and isolate what y is. Now, I'm not going to finish this question. Write that question down for me, solve that equation for me, and you'll see that these two lines are perpendicular.